Good morning, students. Welcome to the last session of this e-learning session, or better to say, last video of electricity. I just want to recapitulate. We have started electricity, you remember, from current. Current, flow of charges per unit time. Then we came upon potential difference. Potential difference, we understood how it is important, the difference between the potence. Then the very important point of this lesson we came upon, that was Ohm's law. V is directly proportional to I, and to solve it we made it V is equal to IR. R, resistance. We have put a constant in it. You remember, students, I gave you a triangle to remember how to remember all those three formulas. After that, we have switched ourselves on two types of resistances. Before that, we have studied four factors affecting resistance. There we got one new formula. It means starting with the formula of current, then potential difference, then Ohm's law, and then we got R is equal to rho L upon A. And then we came on two type of resistances, that was series and parallel. In series you got one more formula RS, in parallel you got formula 1 upon Rp. Like this, near about 6 formulas you got. So this was all about important towards electricity in studying resistance in series and parallel. I took 2 weeks to give you explanation as well to explain numericals, because that was little tough part. Now moving on, the next and the last topic of this lesson, as well it is having numericals also, that is heating effect of electric current. Now heating effect of electric current, it's a very commonly, I can say, experienced topic. We all are surrounded with n number of electric gadgets. As I always say, and when I have started this lesson, you remember in that first video I told you that we people who are living in metros, the fourth basic need of ours is electricity. So we are surrounded with electric gadgets. We are surrounded with fan, we are surrounded with air conditioner, we are surrounded with refrigerator, mixer grinder, ironing machine, many apparatus, even a mobile charger. So all these equipments, one thing you have noticed, one thing you have clearly noticed, that when these apparatus, these things are used for a certain time, after that they are becoming hot, they are giving out heat. That's what is heating effect. Now how that is, let us take out or derive one formula out of this. So I can say heating effect of electric current, the charges Q are flowing in time t, the current I across a potential difference V. This is a supposition. It means charges Q are flowing through a conductor in certain time t, and that current is I, and these all things are under potential difference V. So the work which is done, for example, let us consider a fan. You are enjoying nice breeze of fan. As soon as the button is put on, the fan gives us breeze, air. So that is the mechanical work which the fan is doing. But in spite of this, after some time, when you switch off the fan and if you try to touch the fan is hot. It means the work which is done by the fan, beside that the fan is giving out heat also. It means the power which is used, it is turned in the form of energy, gives heat. So here is a equation called as P, the power which I was talking just now. P is equal to V. It means under that potential difference, these charges were flowing in certain time t. This power which we are calling as electric. So P is equal to V Q upon T, charges flowing in time t. And now as we know that Q upon T, that is charges flowing in time t, is called as current. So this becomes VI. And as I told you that after some time, if you touch the electric apparatus, it becomes hot. It means in the work done, after the work done, heat is also given out. That's why now this P is changing into H. It means this power is transferring into heat, and that gives V is equal to IT. It means potential difference into current and in the time flown. Here you can see this heat which is given out is directly proportional to the potential difference, is directly proportional to the current as well. The very important thing, it is directly proportional to the time also. As much time you use the electrical apparatus, that much heat is given out. So now on this equation, applying Ohm's law, for this V we are applying Ohm's law, and this, as I told you, V is equal to IR. Putting the value of V is IR, it gives I square RT. So this is the one more equation, that is the heating effect of electric current, that is H is equal to I square RT. Next topic is practical application of heating effect of electric current. Now practical applications, just now we have seen heating effect. So now where this heating effect is used? We are having various apparatus where electricity heating effect we are utilizing. For example, an electric laundry iron, electric kettle in which we use to make tea, then toaster, then electric oven, geyser. There are n number of room heater, n number of apparatus where this heating effect we are using. So now how this heating effect is used, I can give you one example which is maybe 2 decades before we were using. We were using an electric bulb. You might have seen the diagram of electric bulb in this way. And this electric bulb was having a filament in it. Nowadays it is not. What we can see, it is extinct. Nobody is using because it is so much power consuming. But this electric bulb is having a filament, and this filament was made up of tungsten, and this tungsten metal is having melting point near about 3380 degrees Celsius approximately. So such a huge melting point it was having. That's why when the current is passed through one end and the circuit is getting completed, when the current is flowing through so much of resistance, tremendous amount of heat was generated. The heat was so much that the coil was becoming red, and due to that redness, light was generated, and that light we were using to come out of darkness at night. But now that is not used. So this was one example in this case, that how we were using an electric bulb. As I named so many heating appliances. One very important use, that is practical application of heating, on which you can get question also in board examination, that is a fuse. In every household appliances as well, in commercial, everywhere, this is a very important heating application, that is fuse. In previous days, the fuse were like this. and a socket to carry the fuse was like this. This was a fuse made with porcelain, and in this fuse we were putting a fuse wire. Now this fuse wire is a very important thing to understand. This fuse wire was made up of certain special alloy. That alloy, if the temperature is raised, automatically melts. This fuse wire is joined in series connection in this fuse, so that when this was attached across the circuit, and if there is sudden increase in current, then as due to sudden increase in current, temperature rises, and due to that rise in temperature, this fuse wire will melt, so the circuit will break. So we can say that this fuse is used as a safety device in the circuit. Nowadays these fuses are replaced by MCB, that is miniature circuit breaker. This is an advanced apparatus which is doing the same work. But now, in those days, if the fuse wire was broken, we have to manually replace the fuse wire. But nowadays in MCBs, if the circuit breaks, the MCB falls down. The lever of the MCB falls down, and just we have to pick it up. Okay. So MCB, that is miniature circuit breaker. See, this is MCB. Okay. This MCB is having this lever. It means when it is in this position, it means the circuit is complete. The circuit is on. And if there is certain problem in the circuit, current rises or temperature rises, then suddenly the MCB trips down like this. Okay. So if it trips down, it means the circuit is off now, and your home appliances and your entire house is safe. So this fuse nowadays is replaced by MCB, and now more advanced are there. RCBs are also there, which are used in more supply power. So in this way, for example, it is written, if you can see it clearly, B16. If you can see it clearly, it is 16. So now this 16 is the rating of this MCB. 16 is rating, means ampere. This MCB can work till 16 ampere power supply. If this MCB is placed across certain circuit in which more than 16 ampere power supply will be there, then this MCB will not work, it will trip always. That's why these MCBs are used according to the consumption of power. This type of question is asked in the CBSE board exam also. Some condition will be given to you, and then you will be asked to calculate current. Then you will get an answer in ampere in current, and then a question will be raised that if such type of current you are getting in this circuit, will certain type of ampere MCB is used, then accordingly you have to answer. Okay, this is all about heating effect. After the practical applications, the last topic of electricity, that is power, electric power. So now the word power is very much familiar to you. Power means rate of doing work. From 6th standard you are studying. Rate of doing work is called as power, but this is electric power. It means rate of doing work means in the work done, energy is consumed. It means the consumption of energy here is electric power. So consumption of energy in the form of power is V into I, potential difference into current. And now here we apply Ohm's law. So this becomes P is equal to I square R. This is first formula for electric power. Or if you apply in the form of I, you will get P is equal to V square upon R. So these are two formulas rather than three formulas of power. Here consumption of energy. Now as this is consumption of energy, so this energy we have to represent or can be explained in some form, that is unit. So the SI unit is watt. Some can pronounce watt, whatever you want. So this is watt, given in the memory of James Watt, given by capital W. So this is also a definition which is asked in board examination many times. What is 1 watt? So 1 watt is the energy used in consumed 1 ampere in the flow of 1 volt. This is 1 watt. So now this watt is a unit to give about power. But when many experiments were done, it was found that this watt is a very small unit. And when this energy consumption was calculated for big motors or companies or at commercial places, this unit was getting very slow. That's why to make it more easy, a reformation was done in this. A commercial unit was introduced, that was 1 kilowatt hour. You know, kilo means 1000 and hour is a conversion here in seconds as 3600 seconds. If we calculate here, we are getting 3.6 into 10 raised to the power 6 joules. Energy we are calculating, that's why the final unit is in joules. So this is a commercial unit of measuring power. The electric bill which we pay every month at home, you know that in that electricity bill you are getting a word unit. It means those many units you have used every month. So what is that 1 unit? 1 unit means this, 1 kilowatt hour. That 1 means 1 converted as 1 unit. It means see the electricity bill of this month, and if you have used, for example, 300 units, it means you have multiplied by this, these many joules energy you have consumed. Okay, so students, this was all about a very important topic, electricity, and this is the last class of this first session. Next session hope will be starting soon. You will be informed by our school. So I am Professor Gaurav, a proud NEFian, telling you these things, and the holiday homework for this is absolutely easy. The NCERT exercise, you go and solve it, try to solve and keep it ready. Hope, let us pray to God that we all will be joining back school very soon. God bless you. Thank you.